Hey everyone, welcome back to my YouTube channel where I will be doing tutoring videos for math. Today we're proving the derivative of e to the power of x. And this is the most common exponential function you'll see in calculus. And once you do this derivative, it's arguably the easiest to work with. And for this derivative, we'll need to know how the number e, which is a constant, is actually defined. And it's defined using one of these two limits. For the purpose of our limit definition, we'll be using the left one. But like with any derivative, the place to start off with is with the limit definition. And you don't have to use the limit definition to prove every derivative, but there are some for which you would, like this. So I wrote the limit definition up here already. So now f of x is equal to e to the power of x. So let's actually get into the derivative. So that means the limit of e to the power of x plus h minus e to the power of x all over h as h approaches 0 is our derivative. And then we can expand e to the power of x plus h as e to the power of x multiplied by e to the power of h minus e to the power of x all over h as h approaches 0. And this is because if we have two exponents like am multiplied by a to the n, this is the same thing as a to the power of n plus n, which is covered in any like algebra class. And I'm hoping it was covered in any algebra class actually, because otherwise I'll have to make another video for it, or I should make another video for it for those who either want to extend themselves or they are falling a little behind. Anyways, without ranting on too much, we have e to the power of x in every term on the numerator, so we can factor that out. And so for now, we'll just keep it outside of the limit. So we have the limit of e to the power of h minus 1 all over h as h approaches 0, and then we can multiply that by e to the power of x. So from here, there are two different ways in which we can do it. So there's one that I ended up using, and there's another one that one of my friends ended up using. But both of these ways work. And for this video, we can cover both of them. So, like I said before, e is defined as the limit of 1 plus n to the power of 1 over n as n approaches 0. In this case, n is h. So, what we can do is, we can just write, so this would just be equivalent to e to the power of x multiplied by the limit as h approaches 0, 1 plus h to the power of 1 over h, all to the power of h minus 1 over h. And it might look like there are quite a few h's, but I promise it will cancel out pretty well. So this 1 over h and h cancel out. So that means we have e to the power of x multiplied by the limit of 1 plus h minus 1 all over h. And so the next step is this 1 and that 1 cancel out. So we have e to the power of x multiplied by the limit of h over h as h approaches 0. The h and h also cancel out. So we have e to the power of x multiplied by the limit of 1 as h approaches 0. And this is where the sudden realization kicks in, that the derivative of e to the power of x is e to the power of x. That's pretty neat, right? It's its own derivative. You don't see that pretty often. Like, in fact, e to the power of x and 0 are the only two functions, or e to the power of x multiplied by some constant and 0 are the only functions that have itself as their own derivative. And you can kind of see the proof for this later on in calculus. This will make more sense. And so now we have the other way. So we have this setup like up over here. So we have e to the power of h minus 1 all over h. So let some variable u equal e to the power of h minus 1. So that means u minus 1 is equal to e to the power of h. So that means h is equal to ln of, sorry, not u minus 1, u plus 1. So that means h is equal to ln of u plus 1. So now we also need to change what this limit actually is, because if we have all of our variables changed to u, we have to change the limit to u as well. So u of 0 is just equal to 1 minus 1. So conveniently enough, our limit is to 0. So this becomes the limit of u over ln ln of u plus 1 as u approaches 0. And so now I think the wise approach would be to divide both the numerator and denominator by u. So we have u divided by u up here, 1 divided by u multiplied by ln of u plus 1 down here, and then the limit as u approaches 0 sign over here. So u divided by u, that just becomes 1. And ln u plus 1, and all of this can be rearranged, because if this was taught in some previous algebra class, I'm presuming, if you have something like ln of a to the power of x, that just becomes x times ln a. So using these same principles, that means we have e to the power of x multiplied by the limit of the stuff to the right. So that is ln of u plus 1 to the power of 1 over u. And so now this seems pretty similar to the limit that's over here. Except instead of being on the numerator, all of this is on the denominator. But the point still stands. So we have e to the power of x times the limit of 1 over ln e as, oh, and this bound should be u, not h, as u approaches 0. And ln e is actually just 1, because ln is log base e. And if we were to set that to x, we would get e to the power of x is e, which would mean that x has to be 1. So really, this just becomes 1. So we have e to the power of x multiplied by the limit of 1 as u approaches 0, which again is e to the power of x. And so now, here are some basic derivatives. I covered the derivatives of sine and cosine in a previous video. I did the power rule in another video, the constant rule, the sum and the difference rule. Let's combine a few of them. What is the derivative of 2 times e to the power of x? Try pause the video and find out. Okay, so for this, we can actually just redistribute the constant outside. So we have 2 multiplied by the derivative of e to the power of x. And the derivative of e to the power of x is itself. So we just have 2 multiplied by e to the power of x. And this just happens to be its own derivative. So this is one of the rare cases where f prime of x is equal to f of x. And so now I think that's a good place to stop for this video. The next video, I'll be covering the product rule and the quotient rule. And this is where you can use a lot more rules to actually find more complex derivatives, especially if you were to have something like x multiplied by e to the power of x. It seems a little complicated now, but I show you with the product rule, it's not. Anyways, thank you so much for watching. Stay tuned for the next video, and like always, please drop any feedback in the comments. And until then, just keep practicing your math.